Alright guys, we're going to begin with our discussion of areas of parallelograms and triangles. This is section 7.1. Okay, a few elementary formulas. I don't think you should have any problem remembering. Square, the area is the side squared. Rectangle is the length times the width. The triangle is half uh, the the height times the base. Okay, so square 5 centimeter side has an area of 5 squared, which is 25 centimeters squared. A rectangle 4 by 7, of course, is 28 square inches. Rectangle 4.6 meters by 2.5 meters. Then the area of the rectangle is the product of those two. Of course, we'll see this on the next page. Okay. The rectangle with length 3 and width 1/2 is 3 times 1/2, which would be 1.5 square feet. Okay. Each triangle is divided into two congruent triangles. Find the area of each triangle. So what we're trying to show here is that, okay, the area of the triangle is exactly half the area of the rectangle. Okay, so the area formula is 1/2 the area of the rectangle. Of course, you could easily compute the area here. We notice is 1, 2, 3 units wide, 1, 2, 3, 4 units. Okay, so it's half of 3 times 4 for 6 square units. This is 2 by 2. Of course, so then that's half of 2 by 2, which is 2 square units. And this is 1, 2, 3, 4 by 4, which is half of 4 times 4, which is half of 16 or 8 square units. Okay, so so we see these, and then we're going to see them in the answers right here. Okay, um, so there's your answers to the previous ones, and you can just keep this when you're going to be working on the worksheets for reference. Okay. Now we are asked to find the area of the parallelogram. Okay. Parallelogram is basically a lopsided rectangle, if you will. You might imagine that I could cut this triangular portion of the parallelogram and push it over, and I would make it into a rectangle. So imagine just cutting this portion out and relocating it over to here, we would have a rectangle. So the area formula for a parallelogram is the same as the area formula for the rectangle. It's the base times the height, okay? And the height is defined as, okay, the perpendicular distance from one side to the other side, okay? Basically, it's the distance between the two parallel sides, okay? Now, it could have a height drawn um, from this side of 10.5, but I have to come down and make a right angle, okay? So the height always makes a right angle. You always have the H there, so or the box there, which makes an H, which tells you it's the height, okay? The area is the height times the base. The area, okay, is going to be 8 times 12. You're given two sides, as indicated, 12 and 10.5. Choose the side with the corresponding height to use as the base. Well, again, the height is given because it makes a box or an H. There's the H. It's a backwards H, but you can put the box over here and be a H right there, okay? So it's half, it's 8 times 12 is going to be the area. Base times the height is the area for a parallelogram. Base times the height is the area for a parallelogram. Base times the height, okay? And the height is the distance between the parallel sides. So there likewise would be a height running to this base of 10.5. And we'll see that in the coming problem. Okay. Some of the problems are going to ask you to plot the points that define a parallelogram. And in plotting them, it's actually going to help you to better find what the area of that parallelogram is. So we give you the grid. We ask you to plot the points A, B, C, D as indicated here. Okay. What's nice is that you could easily determine which height and which base to go with, because here, okay, our height is going to be this distance straight down from B straight down to the origin. And since B has coordinates 0, 5, we could conclude that the height here is going to be 5. That the height here, the height of this segment here is going to be 5, okay? And the base is going to run from A to D, which is a span from -2 in the x value to 6. So that's 8 units that we're spanning along here, and the height is 5. So our area should be 40. So as you can see here, the area is 40. I'm not going to suggest you count squares, okay? I'm just going to suggest that you look at the position, and based on the position, you can easily determine the height and easily determine the base, okay? So the area of this parallelogram base times height is 40 units, okay? All right. Now, if I were to just go back for a minute, likewise, there's a height and a base. If I use the base AB in this parallelogram, then I have to find another height. It'd be a little bit more awkward, but I can work with that formula as well. So in this problem, we're faced with a parallelogram that has 9 inches and 18 inches at its sides. The height corresponding to the 9-inch side is 15 inches. Find the corresponding height to the 18-inch base. Well, what we have to consider is, okay, that the 9 times 15 is going to give me the area, because that's the height corresponding to the 15-inch base. So there's also a height corresponding to the 18-inch base. So what I'm going to do is find the area, the 9 times the 15, and so I'm going to say 9 times 15 is going to give me the same as 18 times x, okay? So the area of the parallelogram using the height and base of 9 as the height and the corresponding base is 15, then I find that my area is 135, okay? But likewise, okay, since that area is not going to change, the parallelogram is not changing its configuration, there's some height corresponding to the 18-inch base, so 18 times x is going to give me 135 here, or 18 times h. So I'm going to work that out and find that the other height in the parallelogram is going to be 7.5. Okay, so so it's basically saying, okay, coming back, okay, we're saying there's a 9-inch and an 18-inch side, and the height to the 9-inch is 15. So 9 times 15 is going to give me the same as 18 times something else. So 9 times 15 resulted in 135. So 18 times h is going to equal 135, and in that case, it's going to be 7.5. Okay, let's go to our area of our triangle now. Again, we said the area of triangle is going to be half the height times the base. Here's our height right here, makes the h right there. Our height is 13, our base is 30. Our area is 1/2 the height times the base, 1/2 of 13 times 30. Easier to take a half of the 30, which is 15, and 15 times 13 is going to give me 195 as my area. 195 as my area. Okay. Here's a interesting problem. I have this garage front. Okay. The configuration of the garage front consists of a 15-foot by 15-foot square with a triangle mounted on top as what we call a gable roof, whose height is 10.6. Now it says, okay, the front of the garage is a square 15 feet on each side with a triangular roof above the square. The height of the triangular roof is 10.6. To the nearest hundredth, how much force is exerted by an 80-mile-per-hour wind blowing directly against the front of the garage? Well, okay, an 80-mile-per-hour wind could knock that garage down. We figure out how much force. Formula for the force is 0.004 times the area times the velocity squared. So we need to compute the area. So obviously the area is going to be the area of both the both the square, 15 by 15, and half of 10.6 times 15. So there's the area uh, of the square, 15 by 15, 225 square feet. The area of the triangular roof is half the base times the height. So that's 1/2 base times height, which is 1/2 of 15 times 10.6, which is 79.5 feet squared. Now, okay, I'm going to next go back into this formula. I know what my area is. It says my velocity of my wind speed is 80 miles per hour, so I'm going to put all that information in. Okay, my total area of the garage front, which is of course the square and the triangle added together, is 304.5 square feet. Okay, and now I go back to my force equation to find the force on that garage front, and putting everything in, it computes to be a force of 7,800 pound force on that um, garage door, which is well, I'm sorry, that's that is yeah, that is the force that is exerted on the garage front, which is a considerable force. Okay, uh, you're going to make reference to this because this has the answers to your exercises that I'm going to be giving you. So it'll be convenient. You might want to come to this and lock on that to watch to check the answers. Okay, as well as these additional problems. Okay, um, and these are interesting ones where we have to draw. For instance, here we're asked to define the area bounded by the triangle defined by the line y equals x. Okay, the line y equals 7, and the x-axis, or the y-axis here. Okay, so there's our area. Here's another one, the area bounded by the triangle with one side being the line y equals negative 1/2 x plus 3, and then the lines, the vertical line, x equals negative 2, as shown here, and y equals 0, which is the x-axis. Okay, so if constructed right, you can easily compute the height and the base and use the formula half the height times the base, okay, for your area. Additional answers here, so you have those for you. I'm going to leave that sit there for a minute so you can stop that and check your answers as well, okay, and additionally the last couple, and some of these which are constructions which we don't do, but we've done them in Sketchpad. So um, final couple questions to consider. The area of the parallelogram, of course, would be the base times the height, so 10 times 15. Find the area of the parallelogram. You have to plot that and take a look at it. Parallelogram has sides 6 and 8. The height corresponding to the base of 8 is it is 4.5. So then we get you know uh, 4.5 times 8 is going to equal the same as 6 times another height. Okay, so we'll figure out what that is. That ends up being 6. Okay, find the area of the triangle here. Of course, it's the half the height times the base. The base here is 6 units, not the extension of the base. It's just 6 units, and the height is 5, so it's half of 5 times 6. This is be an interesting one here. The rectangular flag is divided into 4 regions by its diagonals. 2 of the regions are shaded. Find the total area of the shaded region. Okay, so then it would occur to us that we have, okay, a triangle which is 17 by 11, and another triangle 17 by 11. So we have half of 17 times 11 plus another half of 17 times 11, which is just 17 times 11, which would be 187. So that's our section 7.1 exercises, and you will have worksheets to work on tomorrow to go through. Okay, that's it.